Question number 141. Solve 2x square plus 3y square minus 7 into x dx minus 3x square plus 2y square minus 8 into y dy equal to 0. This is a different question. This is a different question compared to the questions that we solved from this section. The reason being, the questions that we discussed till now was of the form dy by dx is equal to ax plus by plus c by a dash x plus b dash y plus c dash. We discussed the steps needed for questions of this form to reduce it to homogeneous equations and solve from there. But this form has the powers of x and y 1 in this equation. So but here we have x square and y square terms in this equation. We need to use some substitution to convert it into this form if possible to solve this equation. So I will just mark it a star question. I will try to put star wherever there is some unique questions or unique steps or unique formulas that need to be revised carefully so that you don't get stuck in exams while solving such questions. So make sure when you go through the notes, under every question, every video, in the description there is a solution. You can download the solution as PDF if you want, and make sure that whenever you go through solution, whenever there is a red mark or red for something written in red, make sure that make sure to check whether that part is very clear to you, or you know what is written there in red. Okay, so questions that are unique or interesting or where students may get stuck, I will try to mark such questions in red. Okay, so in this question you have x dx and y dy here. That should give an idea on what kind of substitution we should use, and given we are not comfortable with the power 2, we can combine those two and think about the substitution. X square is equal to u and y square is equal to v. So differentiating this equation, let's call our original equation 1 and let this be 2. Differentiating equation 2 with respect to x, we get 2x dx is equal to du and 2y dy equal to dv. So we have x dx here and y dy here, so we can easily apply this substitution and let's see what happens. So using 2 and 3 in 1, we have 2u plus 3v minus 7 into x dx is du by 2 minus 3x square plus 2y square minus 8 becomes 3u plus 2v minus 8 y dy becomes dv by 2. dv by 2 is equal to 0. So rearranging, we get dv by du is equal to 2u plus 3v minus 7 by 3u plus 2v minus 8. So now this equation has transformed into the one that is familiar to us. So we can reduce this to a homogeneous equation using proper substitution. So let's call this equation 4. Now using the substitution, u equal to u plus h and v equal to v plus k. Let's call this substitution equation 5. We have now differentiating equation 5 with respect to x. We have du equal to du and dv equal to dv, or dv by du is equal to d capital V by d capital U. To avoid confusion, so this is small v. Okay, so let's call this equation 6. So using 5 and 6 in 4, we have dv by du is equal to u 2u plus 3v plus 2h plus 3k minus 7 by 3u plus 2v plus 3h plus 2k minus 8. Call this equation 7. Now if you select h and k such that 2h plus 3k minus 7 is equal to 0 and 3h plus 2k minus 8 is equal to 0, the equation 7 reduces to a homogeneous form. So to find h and k, we use 2h plus 3k minus 7 is equal to 0 and 3h plus 2k minus 8 is equal to 0. So we can, so h by minus 8 into 3 is minus 24 minus 4, minus 14. So 14 is equal to k by minus 21 minus plus 16. So is equal to 1 into 1 by 4 minus 9. So whenever we are at this stage, you should check whether a by a dash is not equal to b by b dash. So 2 by 3 is not equal to 3 by 2. That's why we are able to apply this solution. So if that is not the case, we will have 0 here, and we will know that the solution doesn't work when we reach at this point. So okay, so from this we have h is equal to minus 24 plus 14 is minus 10 by 4 minus 9 is minus 5, which is equal to 2. Similarly, k equal to minus 21, which is plus 16 minus 5 by 4 minus 9 minus 5 equal to 1. So we got h equal to 2 and h equal to 2 and k equal to 1. Let's call this equation 8. Now therefore from 5, using 5, we know capital U is u minus h. U minus h is 2, and capital V is small v minus k, which is 1. So let's call this equation 9. We will be using it later. So using 8, 5, the equation 7 becomes dv by du is equal to 2u plus 3v by 3u plus 2v. Now this is a homogeneous equation, as dv by du is a function of v by u. If you divide numerator and denominator by u, you can see dv by du is a function of v by u. It's a homogeneous equation. So in such questions, we apply a substitution where v equal to let's say another variable u, capital U into, let's call it capital U into capital P. We are bringing a new variable here. Sorry, instead to avoid confusion, we will write capital P. We can bring any variable. I just wrote P into capital U. So we'll use the substitution 11. Now differentiating 11 with respect to u on both sides, we get dv by du is equal to p plus u into dp by du. Let's call this equation 12. Now using 11 and 12 in 10, we have dv by du is p plus u dp by du is equal to 2u plus 3pu by 3u plus 2pu. So cancelling out u and bringing p to the RHS, we have u dp by dv, dp by du is equal to, I think my v and u are getting, there is a, so I will write u into du, okay, is equal to 2 plus 3p by 3 plus 2p minus p, which becomes 2 plus 3p, okay, 3p minus 3p minus 2p square. Looks like Argentina scored their first goal in the final match. Okay, minus 2p square. P plus 2p. So simplifying, we have dp by du is equal to 2 minus 2p square by 3 plus 2p. Okay, now this is in form where we can use method of separation of variables. I can understand that substitution with p and all is getting confusing, but yeah, all the terms. Okay, now this is our equation 13. Now bringing all the p terms to one side and u to the other, we have 3 plus 2p by 2 minus 2p square dp is equal to du by u. Okay, now let's open this up. 3 by, okay, we'll do one thing. Let's take 1 by 2 outside first. Okay, so this becomes 1 minus p square and plus 2p by 1 minus p square dp equal to du by u. Okay, now we can integrate this. This is all these terms are easily integrable, so integrating, we have, so we'll bring this 2 to the other side so that it will be easy to integrate. So we have 3 integral 1 by 1 minus p square dp plus so the differential of this term is minus 2p, so we have that already, so we will write minus integral minus 2p by 1 minus p square dp equal to integral um, 2 times integral du by u plus a constant. So this gives 3 into a square minus x square formula. So we have 3 into, okay, we'll just note down the standard formula. So integral dx by a square minus x square is 1 by 2a log a plus x by a minus x. So we are going to use this to integrate the first one. Therefore 3 into 1 by 2a, here a is 1, so 1 by 2 log a plus x, that is 1 plus p by 1 minus p by into minus log 1 minus p square is equal to 2 log u plus c. So we can simplify this further. We multiply, if we multiply throughout by 2 and apply the logarithm properties, we have log 1 plus p by 1 minus p the whole cube into 1 by 1 minus p square the whole square. Since we multiplied throughout by 2, we have this, and is equal to log u raised to 4 into, let's say it becomes 2c. Let's do, if we write 2c as log c1, we can apply log a plus b property and take c inside. So let's say c1. Now we can equate the terms inside. So that gives 1 plus p the whole cube by 1 minus p the whole cube into, so 1 minus p square is 1 plus p into 1 minus p. So splitting, we have 1 plus p the whole square into 1 minus p the whole square. 1 minus p the whole square is equal to u raised to 4 into c1. So here 1 plus p, it cancels out, so it becomes 1 plus p by 1 minus p the whole raised to 5 is equal to u raised to 4 into c1. So now p is from equation 11, p is v by u. We are using that substitution. Using 11, p is equal to v by u. So v by u, if we apply, we get u plus v by u into 1 minus v by u. So u minus v raised to by raised to 5 by u raised to 5. So, and bringing down 1 by u raised to 4. U raised to 4 is equal to c1. So this u raised to 4 and this term get cancelled. So we get u plus v is equal to a constant into u minus v the whole raised to 5. So we got this. Now we can substitute for u and v. What is u and v? If you check from equation 9, u is equal to small u minus 2 and v minus 1. So u minus 2 and v minus 1. We are going to u minus 2 and v minus 1. We are going to plug u minus 2 plus e minus 1. Let me just check. U minus 2 and v minus 1. Sorry. U minus 2 plus v minus 1 is equal to c1 into u minus 2 minus v plus 1 the whole raised to 5. So this becomes u plus v minus 3 is equal to a constant into u minus v minus 2 plus 1 is minus 1 raised to 5. Now if we can substitute for u and v. So what is u and v? U, the initial substitution from equation 2, u is x square and v equal to y square. So we can use that substitution. So using 2, we have this as x square plus y square minus 3 is equal to a constant into x square minus y square minus 1 raised to 5. Okay, let me check whether I made a mistake somewhere. Raised to 5. U plus v. Okay, I made a mistake. No, the final answer is x square plus y square minus 3 into a constant into x square minus y square minus 1 raised to 5. So this is the correct answer. So this is the solution. So there are many substitution. A simple mistake can mess up this whole answer. So make sure that you practice such questions before writing exams. So yeah, this is a solution to question number 141.